Dear students, in the next couple of videos I'm going to talk about the concept of catching up or falling behind. We can be aware that during the long-term developments, certain countries catch up with more developed countries while others fall behind. The difference within the growth rates is a very interesting and exciting question. Actually, we can also raise the question concerning our country. When will Hungary catch up with the average of the European Union? Or the average of Austria? When will it catch up with one of the most wealthiest countries in the world, Luxembourg? Or will it happen at all? We could also think of this problem as follows. Imagine that there is a very long, in fact infinite, running competition, and on the runway there are several countries before us, and we are running after them. The question is, at what average speed can they proceed at the long term? And what is our average speed? Because if our average speed is higher, then no matter that they are in front of us, we are faster and sooner or later we will catch up with them. And the time of catching up, the time it takes, is a very exciting question. It is worth to deal with it. We are going to take a look at several cases, and the first is going to analyze this problem according to the nominal and real GDP. In other words, how many years it takes for a country to reach the nominal or real GDP of a more developed country. Let's take a look at this problem. We say that we would like to compare the economic performance of two countries at a given moment, and if we do so, we shall use the nominal GDP expressed in the same currency. So if we take two countries, for example Austria and Hungary, then we shall take the nominal GDP of both countries, and we can determine which one is the richer, stronger economy at the given time. However, we can only do this if we make the comparison in the same currency. For now, we disregard the purchasing power parity, so we do not adjust the differences in prices. This is a very commonly cited statistic. It is possible to follow up the economic size of different countries. Now let's take a look at the same question from the point of view of catching up. We have a graph where t equals 0 is the initial state, and the axis of t will measure the time, while the axis of y measures the GDP. We have a developed country, which will be marked with red and an asterisk. The initial GDP level of this country is GDP 0, expressed in a certain currency. And there is another country, which initial GDP level is lower, marked with blue. So this is obvious that in the initial time period, the country marked with red is the stronger and developed economy. What happens during the years? The economy of the country marked with red grows. There are several factors determining this growth. Epsilon long, so the long-term nominal GDP, depends on the GDP level of today, that is epsilon 0. Furthermore, on 1 plus g raised to t power, which is the long-term average growth rate during the past years. In other words, this is the growth rate of the real GDP. This is multiplied by 1 plus epsilon raised to t power, where epsilon represents the changes in the exchange rate. It only has a significance when the currency in which we make the comparison between the two countries is different than the currency of the given country. In the case of Hungary, very often we compare the GDP in euro or dollar, although we are using forints. So in this case, also the exchange rate is a determining factor, which we can also project on the long term. Naturally, if the currency in which we make the comparison is the same as the currency of the country, like in the case of Austria, the euro, then epsilon does not change over the years, and actually this is an irrelevant factor. And finally, there is also 1 plus p raised to t power, which reflects the inflation. When we look at the nominal GDP, it is also influenced by the changes of prices. So basically, inflation is also shaping the long-term development of the nominal value of GDP. Alright, let's examine the same with the other country. In the case of country marked with blue, we presume that sooner or later it will catch up the other country. Furthermore, it will also overtake it. The formula is basically the same, but in this case G, epsilon and P refer to the blue country, So these are the growth rate, the exchange rate and the inflation rate valid to the poorer country. So the main question is, what is the point of catching up? Well, obviously everyone can see on the graph that it is the point of intersection, and the time belonging to this point is the time of catching up, marked with TC. This can be determined if we know the parameters, so g, epsilon and p, as well as epsilon 0. But before we get to the calculation, there is one more important remark to be made. If we are focusing on the process of catching up and we would like to make a prediction, so we say that today we are at a certain economic level and another country is also at a certain level, and we would like to see when we are going to catch up the other country, then we should focus on the differences between the real GDP growth rates. Therefore, we presume that the inflation rate and the exchange rate are the same, so there is no inflation difference, and furthermore the changes of the nominal exchange rates also do not influence the time of catching up. Moreover, the easiest way is to assume that the inflation impact in both countries are zero, and the impact of the exchange rate changes is also zero. This is what we will do in the calculation examples. And we are doing this because actually the economic growth, the growth of the real GDP, is what truly drives the catching up. We cannot overcome another country by inflation. If the inflation is very high, that will have serious effects on the exchange rate, or it will cause other internal economic problems. Therefore, the real GDP growth is the key. This is what we will also analyze in the next calculation example. This example uses concrete and real data. According to the database of the Eurostat, the nominal GDP of Hungary in 2018 was 131,935.1 million euro. As we can see, the GDP of Hungary in this case is expressed in euro, and we can also say that it is roughly around 132 billion euro. The nominal GDP of Austria, which is a smaller country regarding the population by the way, in the same year was 386,093.8 million euro. As we all know, the GDP of the Austrians did not have to be converted, since they are using euro as a currency. The Hungarian data, which is around 32,000 billion forints, needed to be converted to euro by taking the average yearly exchange rate. The question is, how many years are necessary for the Hungarian nominal GDP to catch up with the Austrian if we disregard the effects of inflation rate and exchange rate? So we assume that both in Hungary and in Austria there is no inflation, and the Austrian exchange rate will not change, which is true by the way, because the euro compared to euro will not change, and also the Hungarian, the forint exchange rate will not change. So only the difference within the growth rates, the real GDP growth rates, is what we are interested in. We have the following assumption. The long-term average growth rate of the real GDP in Hungary is 3%, while in Austria the same rate is only 1.5%. So the Hungarian rate, the Hungarian speed, is twice as high as the Austrian. If it is true, then the catching up will definitely happen, if this difference is sustainable, of course. The question is, when will it happen? I will show you how to determine this. There is a general formula, the formula of catching up, where we mark the more developed country with an asterisk. 1 plus g raised to tc power, where tc is the time of catching up, multiplied by the nominal GDP 0, this is the value concerning the poorer country, needs to equal 1 plus g asterisk tc multiplied by GDP asterisk 0. So if we multiply the GDP of the initial time with the average growth rate in both countries, we have to get the same result. Obviously they have to equal, because catching up means that the real GDPs are the same. After transforming this formula a little bit, we will get that 1 plus g over 1 plus g asterisk raised to tc power equals GDP asterisk nominal 0 over GDP nominal 0. And from this we can determine TC, the time needed for catching up, by taking the natural logarithm. TC equals logarithm GDP asterisk nominal 0 over GDP nominal 0 divided by logarithm 1 plus g over 1 plus g asterisk. This is basically the general formula of the catching up, and this is what we are going to apply. Applying the above formula to the concrete numerical example, we can say that the time needed for catching up equals logarithm the nominal GDP of Austria in the base year over the nominal GDP of Hungary in the base year divided by logarithm 1 plus the average growth rate of Hungary over 1 plus the average growth rate of Austria. Please be aware that first we need to perform the division and then we can take the logarithm. If we substitute the numbers, we can see that TC equals logarithm 386,093.8 over 131,935.1. As you can see here, we can easily leave out the million. So this is the difference between the GDP of the two countries today. It is divided by logarithm 1.03 over 1.015. If we do the calculation, the result will be around 73.2. This means that with these average growth rates, Hungary needs quite a long time, more than 73 years to catch up with the GDP of Austria. That is the time of catching up in this case. We will follow with more examples in the later videos. Thank you for the attention.